All righty, friends. How y'all doing? How you doing? So, we got used to this idea now of converting between degrees and radians. And math people, they started thinking about, okay, well, how often could that possibly come up? So they took just a generic angle as far as converting between degrees and radians, and they thought, well, okay, we know that there's some sort of circle on here. And we know that some of these points are kind of specific. So we know these points right here. And these are points that we already looked at. And from there, they said, okay, well, this is 0. It could be 0 degrees, 0 radians, doesn't matter. They know that could be 360 degrees. And it also could be 2 pi. And again, this is something we've already looked at here. And so going around the circle here, we had 90 degrees. And we had pi over 2. We had 180 degrees. That was halfway around the circle. And pi. And we had 270 degrees. Or 3 pi over 2. So what ended up happening is they said, what if we put this on a unit circle? If we put this on a unit circle, so the radius is really equal to just 1 unit, so the radius is 1 unit, what would be the coordinates of these points? And this point right here would have been the coordinate 1, 0. This would have been the coordinate 0, 1. And this would have been -1 and 0. And this would have been the point 0, -1. So if they start putting these things on the unit circle, they start seeing different things. Then math people, they started then going, okay, well, aren't there a gazillion like triangles on a unit circle, gazillion radii? And they'd be right. They're probably not a gazillion, probably more actually. And they say, well, every single one of these is going to have some x and y. And they thought, well, it'd be kind of fun or kind of good to know how they in turn deal with this idea of r. So if we called this x and we called this y, we'd find out that cosine of theta is x over the radius, or the radius times the cosine of theta equals x. And so it's a way for us to be able to kind of start to say, all right, we can find out what x is as long as we know what angle we're dealing with and what r we're dealing with. Likewise, they said sine of theta is y over r, or r times sine of theta equals y. But remember, we're on the unit circle. And on the unit circle, the r value is 1. So if we were talking about just the unit circle here, not every circle, just the unit circle, if the r value equals 1, then we plug 1 in for the radius, we find out that the cosine of theta equals x. And then the sine of theta would be equal to y. So in other words, every single point on that unit circle, every x and y point was really nothing more than a cosine theta and a sine of theta. So all of a sudden now it changed a little bit. The math people started realizing, oh, well, cosine of pi, that's the x value at pi. That would have been -1, because cosine of theta equals x. So they didn't have to sit there and try to wonder and figure out on their calculators what things are. They can actually do all this. They could go look at it and say, okay, well, sine of pi over 2. Sine of pi over 2, well, that's the y value. So that means that would be equal to 1, because sine of theta equals y. And this kind of opened a whole bunch of things up here, because now all of a sudden these x and these y's, they weren't just coordinates on the unit circle, they became more than that. So sine of theta on the unit circle, that was always the y value. Cosine of theta was now, if it's on the unit circle, that was the x value. Tangent is y over x. So tangent, y over x, so tangent actually became the slope. And if you knew those, that means you also knew then what cosecant was. It's 1 over y. You knew what secant was. It's 1 over x. And then we also knew what cotangent was. It became x over y. And again, this is only true when it's on the unit circle. It's not on the unit circle. If it's not when our r value is 1, when the radius is 1, these don't necessarily hold true. But they do hold true on the unit circle. So then math people, they started looking and saying, okay, well, if we know that this is true, are there other triangles we can actually somehow go back and deal with? So they started thinking about triangles that they could work with. And some of the triangles they started thinking about went back to our geometry. They went back to our 30, 60, 90 right triangle. 2x, x, and x root 3. They went back to the 45, 45, 90 right triangle. Which was x, x, and x root 2. Because they knew that those were triangles that we actually knew the exact value for. So they tried to figure out where they'd find those on the unit circle. So the first time they'd find out would be here at 30 degrees. So 30 degrees. And if you wanted to know what that would be in radians, we could convert that. 30 degrees is, what would that be? Pi over 180 times 30, which is pi over 6. Because each of these degrees was equal to a radian. So once they knew where that was, it was a matter of trying to figure out then what point went with it. So they came back here and they said, all right, at 30 degrees, we know then that these are going to somehow tie together. So if the radius is 1, so if 2x equals 1, that meant x was 1/2. So the y value would have been 1/2, and y is sine, so sine was 1/2. The x value would have been 1/2 times √3, or √3/2. So the cosine value would have been √3/2. So this became the point. 1/2, I lied, √3/2, comma, 1/2. Where x, the √3/2, the x value, that would be your, I almost got to it. That's a really tough number to get. There we go. The x value is your cosine, and the y value is your sine. So cosine of pi over 6 is √3/2. Sine of pi over 6 is 1/2. And again, we could do all the other ones, find out what the other 4 would be as well. So then they went and said, okay, well, what's the next one we can come up with? What if it was a 45-degree angle? So if it was a 45-degree angle, so before we did that, I had to figure out what that was going to be in radians. So pi over 180. By the way, I need to go here to my desktop because I just realized when it reset me, my computer reset on me today and I didn't have my notes up anymore. So we're gonna need to pull that up here, have that ready to go. It disappeared on me. Maybe it's here. Sorry about this, guys. There we go. We're just gonna, you won't see it yet, but I need to see it. Got it. All right, so then from there, they converted it. And it became pi over 4. So 45 degrees was the same thing as pi over 4. And so when they started looking at that, they started putting it all together here for that one as well. Going, all right, well, let's figure out what that triangle is. So if we had our 45-degree angle, and we know our radius is 1, that meant x √2 was equal to 1. So x was 1 over √2, which is the same thing as √2 over 2. So this became √2 over 2, and this also became √2 over 2. So the cosine and the sine of 45 degrees, or the cosine and sine of pi over 4, well, they were the same value, √2 over 2. And since x and the y are the same, turns out tangent was equal to 1. And so then there was one other angle on the unit circle that they wanted to deal with, and that became the 60-degree. So 60 degrees, and then you have to figure out what that one was. So r equals pi over 180 times 60 degrees, which is pi over 3. So the pi over 3 one, that was the 60. So that one became the 30, 60, 90 triangle flipped. So the 1/2 went from being the y value to the x value. And the root 3 over 2 came over here. You can kind of get back to that complementary idea, how the cosine of sine equals, or the cosine of 30 became the sine of 60, and so on and so forth. So we have that point. And then what happened from there is math people said, okay, well, you know what? We can create these 60-degree triangles all over we can create those 60-degree triangles in every quadrant. We can create the 45-degree triangle in every quadrant. And we can create the 30-degree angle in every quadrant. And so what happened here is they realized, hey, we can actually find the exact trig values for 16 angles on this unit circle. And that came to be known as this. We're going to get a new share. That's why I had to pull up the notes real quick, because for whatever reason I didn't have them pulled up. Don't really know when. Oh, there's a thing on this side that says restore. Yeah, you already made it delete. So we end up with something that looks kind of like this. And so if you notice, as you're going around here, all these angles, 45-degree angles, ended up being pi over 4s. And notice how they have the same x and y coordinate all the way through. They were always root 2 and root 2 over 2 and all of them. And think about it. X and y. X is positive and y is positive here. Over here, x is negative in quadrant 2 and y is positive. So friends, if you notice, x was negative. In quadrant 3, they're both negative. And lo and behold, they are both negative. And in quadrant 4, you would expect to see the y value negative. So all of a sudden, every trig function is going to be positive up here in quadrant 1. In quadrant 2, since y is positive, that means sine is positive. In quadrant 3, since both x and y are negative, that means sine and cosine are both negative. That would have meant tangent would have been positive. And down here, the cosine, the x value is positive, so cosine is positive. And so we find out, we can kind of determine where our trig functions are positive. All of them are going to be positive here. All sine is going to be positive here. Tangent would be positive down here. And cosine would be positive right here. And friends, just remember that you're in pre-calculus because all students take calculus. That's where you're heading here. So just a little acronym there to help you remember what it is. But notice, again, all the root 2 over 2s, they come from our special triangles. If we keep going down here, we look at our 30, 60, 90 triangles, and notice all the 30 degrees are pi over 6. All the 60 degrees are pi over 3. In class, we'll work through a little acronym on how we can remember all the different angles and all that kind of stuff. And we'll put it together as one unit circle. But we have our 2 unit circles here. The x value is always cosine, the y value is always sine. And another way to remember that x is cosine, y is sine, just think of the alphabet. X comes first in the alphabet, just like, so X comes before Y, C comes before S. Think alphabetical. First letters, X and cosine. Second letters, Y and sine. And we end up going through here. So we can use this now to come up with all of our unit circle values. So why don't you guys go ahead and pause the video and use your notes to see if you can actually figure out what all these values would be. All right, go for it. All right, let's see how you guys did. So cosine, that's an X value. So we're looking for the X at 2 pi over 3. So you go to your unit circle, you try to figure out what the X value is, and it would have been -1/2. Sine is a Y value. So what's the Y value at 5 pi over 4? That would have been -√2 over 2. And guys, you're eventually going to have this memorized. You won't have to keep going back to the unit circle. I'm going to help you out because I'm going to give you quizzes on it. But you'll eventually get better at it. So tangent is 7 pi over 4. Remember, tangent is the same thing as y over x. So what is y over x at 7 pi over 4? So let's see here. The y value, that was the -√2 over 2. And the cosine value is a positive √2 over 2. So that would be equal to a -1. All right, cosine, that's an x value. So that would be, the x value of pi over 2 is 0. Sine of 3 pi over 2, that's a y value. So the y value at 3 pi over 2, -1. The x value at 11 pi over 6, and again, you guys just keep going back to your unit circle, √3 over 2. Tangent is 7 pi over 6. All right, so that's going to be, again, y over x. So on your unit circle, you would have found the y value would have been -1/2. -√3 over 2. They both have 2 in the denominator, so I can get rid of it. And they're both negative, so it's 1 over √3. Unit circle angles are the only ones we have to rationalize. So we do need to rationalize this. This is √3 over 3. Cosine is an x value. So the x value at 5 pi over 3 is 1/2. Sine is y. So the y value at 4 pi over 3, that would be a -√3 over 2. Cosine of 2 pi, that's the same thing as cosine of 0. Cosine is the x value, that would be 1. And tangent, y over x. So at pi over 2, the y value is 1, the x is 0, so therefore tangent is going to be undefined. Tangent at pi would be y over x. So that's going to be the same thing as 0 over 1, or -1, which is 0. All right. Okay, so let's try some more of these here. What if I give you some more angles to play with here? And again, what I want you to do is I want you to pause your cosecant of pi over 4. What I want you to do is I want you to pause the video after I put these up there. Go back to page 1 of 4.2 here. And I want you to use your unit circle to help you figure out what these are. We have cotangent. cosecant. Let me write these up here first for you. We had secant. So 5 pi over 6. And we had cotangent. 4 pi over 3. All right, friends, why don't you guys go ahead and see if you can figure these out, and we will come back and talk about it. All right, so before I do this here, let's remember what these are here. So cosecant, I got a couple different ways I can look at it. I can look at cosecant as 1 over sine. Maybe you might want to think of it in terms of sine. You can go that route and do the reciprocal of it. Or you can think of it in terms of 1 over y. So whatever you honestly want to think of it as. Secant is 1 over cosine. Or if you want to think of it in terms of x and y, it was 1 over x. So either you're going to figure out what cosine is and do the reciprocal of that, or you're just going to go get the x coordinate and do the reciprocal of that. So it doesn't really matter what you do. Each of you guys are going to kind of have your own separate way to do this. Some of you are going to think of more in terms of sine, cosine, and tangent because you like that better. Some of you might think of it more in terms of x's and y's. That's okay too. So cotangent of theta is the same thing as x over y. So you can take your pick and figure out which one is the easiest for you. So, for instance, if I were to do this one in terms of sine, so cosecant, some of you guys might try to think of it in terms of this. What's sine of pi over 4? Sine of pi over 4 would be root 2 over 2. So cosecant then is the reciprocal of it. And then you would simplify it. So 2 root 2 over 2, which is root 2. That's how some of you guys will go about doing this. And you'll say, oh, it's root 2. Some of you are going to look at it and you're going to do it this way. Cosecant of pi over 4. That's going to be 1 over y. So I'm going to have 1 over root 2 over 2. And go back to our complex fractions like we did first semester. 2 root 2. And notice it still puts you in the same spot. You just have to figure out which one makes the most sense to you. Are you a sine and then do a reciprocal, or are you just a 1 over y? It doesn't matter. You take your pick. So guys, go ahead and pause the video here and see what you guys end up dealing with. Okay. All righty, let's see if we can try this here. So 1 over x, I'm going to do it this way. And then 1 over x would be 1 over 1/2, which is equal to 2. For the other secant one, I'll do it the cosine way. So cosine is of 5 pi over 6 is negative root 3 over 2. So therefore, secant is the reciprocal of that. So negative 2 over root 3, which is the same thing as negative 2 root 3 over 3. All right, let's try the cotangent ones. Cotangent, instead of y over x, we are now x over y. So the x value, this one is root 3 over 2. The y value is 1/2. That'd be root 3. Cotangent and tangent, I usually just do those as x over y as y over x's. I find it easier to do it that way. I mean, you could find tangent on these if you wanted to. It's not really going to save you a lot of time, but it might if it helps you out. So that would be a negative 1/2, a negative root 3 over 2, because it's x over y. So that would be a positive 1 over root 3, which is root 3 over 3. And let's see here, cosecant of pi. I can do that real quick. That's going to be 1 over y. So 1 over the y value, that one is 0, so that would be undefined. All right, let's keep going a little bit here. Keep going a little bit more. Today's a little bit longer of a day. The next video will be a little bit shorter. So here we can see kind of where they're all at there. All righty, let's play around with a couple of these here and see what we can get here. So theta of negative 3 pi over 2. So first thing I need to know is where the heck is negative 3 pi over 2 at? So notice this is going to take our curve sketching here, or our angle sketching we had before, to help us figure out where we're located. So negative 3 pi over 2 means I'm going to go in the negative direction. Negative pi, negative 3 pi over 2. So that's right there. So the point then on that one, that's the point 0, 1. So now I can figure it out fairly quickly. Sine is y, cosine is x, tangent is y over x, so that'd be undefined. Now the cosecant is going to be the reciprocal, so reciprocal of 1 is 1. Now the 0 is kind of hard to see what the reciprocal is, but this is technically 0 over 1. So the reciprocal for it is 1 over 0, which again you can't have, so that would also be undefined. Cotangent, it's tangent in the reciprocal, so 0 over 1, which is 0. And remember what we said about cotangent? We do the complementary function. So that one of the best ways to figure out what the complementary function is literally just write the word cotangent. And if it has co, cross it off. If it doesn't have co, add it in. So cotangent, it has a CO, so we're going to cross off the CO, and we'd be left with tangent. So cotangent of pi over 2 minus theta is the same thing as tangent of theta. So tangent of theta, what value was that? That was undefined. All right, friends, why don't you guys go and pause the video here and see if you can't try the next one. All right, so notice this one's going to get into coterminal angles, isn't it? So if I'm going to spin it around here, 19 pi over 6, I have to subtract 2 pi from it. 19 pi over 6 minus 12 pi over 6 is 7 pi over 6. So that's where I'm at. I'm at 7 pi over 6. So I got to make a quick rotation. I'm going to go all the way around. There we go. So 7 pi over 6. So what I need to know is the unit at the unit circle. What is the coordinates at that point? That'd be negative root 3 over 2 and negative 1/2. If we know those, we can go through and we can answer everything else here. So sine negative 1/2. The reciprocal of it will be cosecant. That'd be negative 2. So negative root 3 over 2. And the reciprocal of that will be negative 2 root 3 over 3. Now, some of your guys are going to go, how did you get from there to there? Well, first of all, you're going to do that reciprocal a lot, so you're going to get used to it. Here's how I got there. So to do the reciprocal, I flipped it. Then I got to multiply top and bottom by root 3, so negative 2 root 3 over 3. The unit circle ones are the only ones where we have to rationalize the denominator. Tangent. Tangent for this one, again, it's going to be y over x. So negative 1/2 over negative root 3 over 2. That would be a positive 1 over root 3, which is root 3 over 3. Now for cotangent, when I'm doing my reciprocal, I could take the reciprocal of this one right here. I could take the reciprocal of this one here. I could take the reciprocal of this one here. I'm going to do this one because it's the easiest. If I take the reciprocal of that, I get root 3 over 1. And that makes it root 3. All righty, and then I got my complementary function again here. Let's write that in there. I got secant there we go. And this one did not have a co, so I need to write the letters co in front of it to see its complement, and it would be cosecant. So secant of pi over 2 minus theta is the same thing as cosecant of theta, which would be negative 2. All right, friends, let's try a couple more here. All righty, why don't you guys pause the video and try both of these, see what you come up with. All right, let's see how you did here. Let's figure out, first of all, 11 pi over 6. Good news on this one is it is on our unit circle, so I don't have to do any coterminal angles there on that. It's right there. So we want the point that goes with it. And that would be root 3 over 2 and negative 1/2. So negative 1/2. Reciprocal would be negative 2. Cosine is root 3 over 2. And the reciprocal of that is 2 root 3 over 3. Tangent, that's going to end up being y over x. So negative 1 over root 3. Can't have the negative in the bottom. So I get negative root 3 over 3. Cotangent is going to be the reciprocal of it. I'm going to take that root 3 over 1. Do my reciprocal over that one. It doesn't matter which one we do it on. Your call. And then sine, write the function. There's a co in front of it, cross it off. If there is no co, write it on. I am missing a co, so I got to write it on. That means the complementary to sine would be cosine. So what was my cosine value? It was root 3 over 2. All righty, now on this one, you had another one that didn't fall in on the unit circle, so we had to go and do a coterminal angle. So 675 minus 360. And you guys came up with 315, hopefully. So that's the angle we're playing with here. Let me sketch the angle real quick. Let's see, I had a full rotation. And then I came down here. All right, let's throw our point on there. Whoop. And we end up with the point root 2 over 2 and negative root 2 over 2. So sine the reciprocal of root 2 over 2, though. I don't know that we've done that one yet, so let's try that one real quick. All right, so root 2 over 2 would become 2 over root 2. Oh, we did this one, actually. So I did the reciprocal of negative root 2 over 2, became negative 2 over root 2. So we end up with negative 2 root 2, which is negative root 2. All right, cosine, positive root 2 over 2. So secant then is going to be positive root 2. Tangent. All right, let's deal with tangent real quick. That's going to be y over x. So we end up with negative root 2 over 2 over root 2 over 2. So negative 1 over 1, which is a negative 1. The reciprocal of negative 1 is negative 1. All right, then we have our tangent. There is no co in front of it, so I'm going to add co in front of it. If there was, I'd cross it off. So the complement to tangent would be cotangent. So cotangent of theta, which would be negative 1. All righty, friends. So close to the end here. Just got one last little thing to talk about here, and that would be even and odd. Now, we dealt with even and odd back with polynomials, and it turns out we have the same thing. It turns out that cosine and secant are even functions. That meant cosine of theta equals cosine of negative theta. And the secant of theta is the secant of negative theta. Turned out also that sine and tangent, that they would be odd functions. So if we can remember that, it actually ends up being something that's not really too terribly hard to do when it comes to dealing with even and odd functions. So if I see cosine, I know that cosine is an even function. So that means cosine of theta equals cosine of negative theta. So if cosine of theta is 1/4, that means cosine of negative theta also equals, or cosine of negative theta also equals 1/4. Let's try it for the odd function. If it's an odd function like cosecant is odd. That means cosecant of negative theta equals negative cosecant of theta. So if cosecant negative theta is -7/4, that would be equal to negative cosecant of theta. So in this problem, though, notice I don't want negative cosecant theta. I want a positive cosecant theta. So that means 7/4 would be equal to a positive cosecant of theta. So just a real quick timeout. You're not going to do much with this, guys, but realizing that we are also going to have some even and odd function that kind of pops up a little bit. Just remember what these relationships are, and you'll be in great shape. Okay? Remember what those relationships are, you will be in great shape. And again, biggest thing to remember is just go back to what did we say those definitions were back when we were dealing with functions, because the same thing will be true with our trig. All righty, folks. Well, that takes care of us for today. Have a good rest of the day, and I will see you guys tomorrow.